to Plans, Elevations and Isometric Drawings. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so today's video is all about how we can take a 3D shape and represent it using 2D visualizations. So the first one we're going to look at is looking at the plans and elevations, and all that means is we're going to look at the different viewpoints of this 3D shape. So I've built a shape out of blocks, and all I want to do is I want to see what it would look like if I was looking at it directly from the front, what it would look like if I was looking directly from the side, and what it would look like if I was looking directly from above. Now, just to help you visualize this, I'm just going to show you a little animation of the shape. And so here we have the original shape, and as it turns, we'll see different viewpoints. So we can see the side elevation. Now there is a left side and a right side. We'll also see the front elevation. That is the appearance directly from the front. And then we will see what is called the plan. The plan is the name for the view from above. Now what you will notice is as you look at the different shapes, even though there is depth involved, once we start looking at it directly straight on, the shapes become flat. And this is a way of showing that we can what we can see as we look from those different angles. So what we're going to do is I'm just going to show you a method for doing this, and this is something you may have seen in design technology, as this is an orthographic view. It is showing the front to begin with, and then using the dimensions of the front to design the plan view above and the side view to the side. And so what I've done is I've just taken the front view. Now obviously we can see that the front view has these three squares here in an L shape, which are the three squares I've drawn here. But also, as we look from the front, we would also see this face of the cube here, the square here. Now I've drawn dotted lines to show that in the front view, the three here we would see at the front, and the one here would be at depth, but because we're looking directly straight on, it is flat. I've then drawn in these guidelines. The guidelines to the sides are there to show us that the width of this shape can never go beyond 2 squares, because that's what we saw from the front. And so when we look at the plan view, the plan should fit in between these gaps. And so as we look at it from above, what we see is that it is an L shape again. And that L shape, here it is, the L shape has 2 squares going along, and then 1 and up and along and down. And so our plan view fits exactly inside of those guidelines and is in the correct orientation, because what we've done is we've gone from the front and moved straight to the top, and there it is, making the L shape. Now the side view, this depends on which way you're looking at it from. I'm looking at it from this side as my side view because I've made my lines go to the right. So I'm going to look at the right hand side of the shape. And if I do that, again, the guidelines are telling me that at most it must be 2 squares high. It can't be any bigger than that. And what we can see from the side is that it goes up 2 squares and it has a width of 3 and then up 2, and it makes almost like a U shape. Those would be our front, our side and our plan views of this shape. So next we don't have this time an animation to show, so we're just going to have to try and visualize what this shape would look like from its different viewpoints. I've started off with the front. Now the front is always looking in this direction here. And the front you can see is just an L shape. It's a little 3 square L shape. And what I've done this time is I've drawn in once again these guidelines, and I've taken it this time from each of the different corners of the shape, just so I can be sure when I draw my new shape that everything is in line. And so I'm going to think now, what would it look like as a plan view? So looking directly from above on this shape. Well, if I look from above, I know I'm going to see two squares on top of each other, and also if I have here two more squares on top of each other. But if we were to look at this directly from above, what that would form would be two squares that were directly on top of each other, but also two more squares right next to it and perfectly in line. And so what we'd actually have here would be a square looking directly from above. Looking at the side view, which would be coming from here, well, I can see that on the side view, I would see these two squares, and then I would see these two squares. And again, because we are looking at it directly, these are going to become flat. Rather than the depth we can actually see that exists, we're going to have two squares at the bottom and two squares at the top. And you'll notice that where we drew the guidelines in, that is telling us where the depth is involved within the shape, because now we can see this line matches directly with the corner, and that is because of this point here, where if we were looking from above, we would see two squares and then two that were lower down, and at the front I'm using this line here. There are the first two squares, and then the depth that we would see, the two behind it, are above. So one more. Let's have a look at this shape. This is a shape made from 4 cubes, and it has a T shape to the front. And so again, what I've done is I've drawn the front as my first view, and then I've drawn in guidelines from each corner of the shape so that I can make sure that my different views that I show all match in size and dimension. And so let's think about from the front going straight to the plan view, so looking at it from above. What would I see if I look directly from above here? Well, I know for certain that I have a square. There is one square definitely right at the top. But if I was also looking down, I would also see the square here, and I would also see the square here. And so how would they look if they were all as one? Well, they would be a single line. They'd all be in line with each other, and so we would have 3 squares all in a perfectly straight line. From the side view, well, the side view, we're going to be looking from the right, and so we'll be looking in this direction, and we would obviously see this face here, but we'd also see this one here. And so we have 2 squares. Well, I can draw that straight away. I know there's going to be 1 square here at the bottom. But then if I was looking at the one above that, well, it would look like it was all one piece. So it would become a single rectangle. But again, the lines that I've got drawn in here, they are demonstrating depth, a change in depth between the shapes. And so the line here is telling me that there was a change in depth from this first square that was in the middle to this one here. And then at the front, this line is showing me that from here to here, there was a change in depth. The next method that we're going to look at for representing a 3D shape in 2D is using isometric paper. And so isometric paper is this dotty paper here. And what you'll find is that each of these lengths is exactly the same. This is 1 centimeter isometric paper. Therefore, this length is 1 centimeter. This length is 1 centimeter. But also, the distance between the points vertically is also 1 centimeter. And so we have what is known as as isometric paper, because every direction and every direction between the points is the same length. Now, what I want to do just to begin with, before we start trying to draw what is quite a complicated shape, I just want to begin with a single cube. How would we draw a single cube on isometric paper? Well, for me, I will always start with a little diamond at the top. So I've drawn myself a diamond. If I then draw a line straight down and straight down and straight down from the 3 corners that I can see and join those together, what I have done is a perfect representation of a cube. We can see each of the faces, the top, the side and the front of that cube. And if we want to do that again, we'll just go diamond, drop down 3 lines and join them together. And the beauty of this is that we can keep building from there. If I wanted to make a little tower, well, I could just add some more legs and join them together. I now have a tower with 2 blocks. And if I wanted to go tower with 5, well, let's just add some more. I've created a tower with 5 blocks, and you can fill in the lengths here as well, just to make sure that they look like cubes. And also, if we want to keep building different shapes, we could also then keep adding on to the sides as well. We could add length here. We just need to make sure that when we draw in the top, we keep to the idea of the diamonds being available on the top of the shape. And so we would keep drawing. And what we start to find is that certain parts of the shape, we can't actually see it all. So if we look just here, we only actually see half of the top. That's because it's hidden behind the tower of cubes that we created. So let's have a go at drawing the actual shape that we have here. So when we begin, I want to start with a cube where I can see all 3 sides, the plan view, the front and the side. And so I'm going to start with this first cube here, and that is a single cube. So we're just going to draw our original single cube. There we go. So there's our first cube. And then all I want to do is I want to think about, well, what can I actually see from here? Now, if I continue down, I can see the side and I can see the front. And so I'm going to continue this shape so that I can see the side and the front of the bottom cube. And so I have now added this cube and this cube. Now, the other two, this one, I can see a bit of the top and I can see the front. And so I'm going to do this with this cube. Now, what that means is I need to continue in the direction that I am moving. So here, I'm going to the left. So from the cube that I've just drawn, I'm going to the left. And so I'm going to continue that here. Continue to the left. 1 cube. And there's another one after it. So let's continue it for a second cube. Then all we need to do is finish off the tops of our cubes, the plan views, and so we will draw this. And what we can now see is if I just colour this in, we would have a full top that we could see, a full top that we could see, but this one, there is a little bit hidden. And you can see that here, we've only got part of the top. In terms of the front, well, we've got 4 full faces there that we can see. We can see everything about the front, and you can see that here. All 4 of those faces are visible. And then on the side, well, we've got 2 cubes on top of each other, and we can see those 2 faces there. What we have is a 3D version of this shape, but drawn on 2 dimensions. Let's try it for this shape. This shape is made from 4 cubes again, and this time we have a cube on top of 3 at the bottom. Now, in order to draw this, once again, all I want to do is I want to have a look and see, is there a cube where I can see all 3 faces? Well, in this case, there's this one, and this one. So I've got a choice. What I would always try and do is to try to work from the top down. And so when drawing these shapes, start from the top and work your way down. And so let's just begin once again with a single cube, drawing the legs and join them up. And then we just need to have a look at the shape itself and see, well, how do the lines continue? So we've just drawn this line here, and it's this one. Now if we look at the shape, it continues one square along. And so if I do that here, I continue that shape one square along, it then moves to the left. And so we need to do that here as well. We need to continue it to the left. And what we'll notice is that this is actually the top of a new cube, and therefore that should be a diamond shape. The rest of the cube is visible, and therefore we just need to finish off our cube. And so there we go. So now we've drawn two of the cubes that we can see. The third one, now this one is a little bit more complicated. We know though that there is a top piece that we can see, and the top piece uses the line that we have here. And so what we just need to do is create our top piece, our diamond, finish off with the legs, one leg is already there, and then join together. And now what we can see is exactly the shape that we started with here. If we look at the different views again, we could see three top pieces, and we have that here, 1, 2, 3. We could see three front pieces, here, here, and here. And there they are. And we could also see three side pieces, here, here, and here. Okay, let's try one more. We've got another shape made from 4 cubes, and it's quite similar to the first one that we looked at. It's the same shape, just in a different orientation. But that is very important, because the shape is different because it is now in a different orientation, and therefore it should be drawn slightly differently. And again, all I'm going to do is look for a cube where I can see 3 faces and start from the top. Well, it's going to be this one at the top here. And so let's just draw a single cube to begin with. And then have a look at the shape and see what else we can see. Well, the one beneath it, we can only see the front and the side. And so I can add the front and the side. The cube beneath that, we can only see the front and the side. So we can add a front and a side. And then we come to the final cube. Now this one, again, we just need to think about how that is actually being built. This is the line that we've just drawn here. Now if we continue, it goes one more to the left, and therefore our shape must go one more to the left. And it then has a full face, and therefore let's add in the full face. Now the top has a little piece of it hidden behind the column here, and therefore we just need to finish off our top piece. And there we go, we've built this shape. And again, let's just have a look at the different views. The top, we can see one full piece, and there it is, but one piece that's got a little bit hidden. There we go, only half of a face. At the front, we can see the full L shape, which we can see here. And then from the side, well, we know there are just 3 right on top of each other. One there, and one there. And so our last challenge is to bring all of that together. Now, if we are shown the different elevations of a shape, can we turn it into a 3D drawing using the isometric paper? Now, this does take quite a lot of visualization. You've really got to think carefully about what we are seeing from the different views. So if I look at the combination that I have here, I've got a front which has a height of 2 with then a height of 1, and a side view that has 1 and then 2. This is an important combination because it means that because the first piece here is only 1 square high, it means that there must be an element of depth here. So along this line, there is an element of depth that creates the change in the side view. And so the first thing I'm actually going to do is I'm just going to draw in the cubes that would be represented here. So that would be 3 cubes in a line. 1, 2, 3. So let's draw those in. And so there is the front view. Now, because of this change in depth, what it actually means is that this cube here, which would be this square, this one must just be on its own. These 3 cubes don't have any additional cubes above them. It then comes to making sure that from the front, which is looking here, if this is the front, we should see another cube above this. Now that means there must be some depth involved, and so to deal with that depth, we're going to build our next cube on top here. Now currently, if we just have a look at this cube, it's not actually attached to the shape. This cube is almost floating in the air because there is nothing supporting it beneath. And what that would mean is if I was currently looking at it from the side view, which is from here, the side view, all I would see currently is this cube from this face here and this cube from this face. We're missing the one that's beneath it. And so to deal with that, I need a cube underneath. So let's drop a little line down. If I were now to look from the side, well, I would see 1, 2, 3 cubes. I would see this full shape. If I were to look from the from the front, I would see 3 in a row and 1 above it, 3 in a row and 1 above it. And the last little test here is from the top, the plan view, do I see an L shape like this? Well, I have 1, 2, 3 shapes next to each other and then 1 above. I have that L shape from above. I've created a 3D drawing of that shape. Okay, so again we have 3 different views of a shape, the front, the side and the plan, and we want to try to draw that 3D version of it. And so in this case again, we've just got to keep thinking about that visualization. In this case, the front is a little group of 3 cubes, and then the side has the same height. Now that is telling me that actually that is a good clue that we can just get going straight away with drawing in the front of the shape. The front of the shape should just be a little L shape, and so there it is. And we'll just draw in the lines just to make it clear where the squares and cubes are. So from the front straight away I can see that I've got all 3 pieces that I required. I've got the L shape. From the side, the key here is that I need to have 3 cubes and followed by 2 cubes. Now the 3 cubes are at the base, and so using the bottom part of the L shape, I'm going to create 3 cubes in a row. 3 cubes going straight across, and let's draw all 3 of them in. 1, 2, 3. And so now from the side, I definitely have the 1, 2, 3 for the bottom, but I also need 2 from the top as well. I need 2 along the top of this. So let's just draw those in. 2 across the top. And so let's just check. Have I got the formation that I would expect? 3 along the bottom, yes, and 2 across the top, yes. Now the last part is, does the plan fit this version? Well, the plan is showing that we have 2 in a row, and then 3 in a row next to it, 3 in a row next to it. We have a perfect version of that shape in 3D. And so we end with the exam question, and this came from the Edexcel paper in June 2017, and it was on both the foundation and higher papers. And so this is a crossover question, a grade 4 to 5 question, and it tells us that the diagram shows a prism with a cross section in the shape of a trapezium. On the centimetre grid below, draw the front elevation and the side elevation of the prism using a scale of 2 centimetres to 1 metre. So there's an awful lot to unpack from that question. Now, first of all, we haven't really looked at any shapes that weren't just made of cubes, but we can still use plans and elevations for any type of shape. The next thing is the direction of these arrows. You've been told that this is the front view. So that is important, that when you label it, that you label the front as the shape that you would see from the front, and from the side that you show exactly what you would get from this view. And lastly, we also have a scale in this case. We have a scale drawing. It's 2 centimetres for every metre. So we must make sure that when we start drawing our shape on the squared paper, we think about that. And so the first thing I want to just do is have a think, what would we actually see from the front? Well, the front is this view here. And if we just do a quick sketch of what that would look like, we have a straight bottom, flat bottom, with right angles either side, and then it goes up a little bit, and then it has a straight side here. We have a trapezium, and the key here is that this is 2 meters across. Okay, so that's where I'm going to begin with. I'm going to begin with my 2 meters across, but it is 2 centimeters to 1 meter. So the first thing I'm going to do, 2 centimeters for every meter. Well, there's 1 meter. There's 2 meters. It's going to be 4 squares across. It is also 2 meters high, and therefore I'm going to draw exactly the same thing going upwards. 1, 2, 3, 4. Then this length is half of a meter, and therefore if 2 centimeters is 1 meter, how do I get half of a meter? Well, half of a meter would just be 1 square. This length here, it says it's 2.5 meters, but we don't even need to measure that, because all we know is it joins this piece to this piece. And so what we've got here is the front, and we'll label that as the front so that we can make sure we definitely have the right piece in the right place. Now comes our little trick that I showed you with the guidelines, because we can make sure that we definitely have our side piece all looking correct by just adding in little guidelines from each of the corners, because the side must match up with the front. And so all we then need to do is make sure we draw everything accurately. So from the front we can see that this is 1 meter, and therefore 1 meter is 2 centimeters, and so we're going to draw in a line which is 2 centimeters high. And if we were looking, we would definitely see from this side a rectangle, and the rectangle must meet exactly the same point as our guideline. And then this is where it becomes quite complicated. This is obviously a sloped edge, and so in terms of our depth perception, we would notice that this piece was further back than this piece, until we looked at it directly straight on. It would become completely flat. And so now the different shape here, it would just be a perfect rectangle. That's all we would see. And the guideline has shown me where that rectangle should end. And so the side view would be 2 rectangles on top of each other. And it is important that we have this line, because that denotes the change in depth. And so this view would be the side.